Welcome friends. In this new video we will see some properties of the divided differences. We have seen the definition of divided differences. The divided differences, first divided differences is denoted by f of x0 comma x1 or two values of arguments x0 and x1. Then by definition this is f of x0 minus f of x1 divided by x0 minus x1. We write this as f of x0 divided by x0 minus x1 minus f of x1 divided by x0 minus x1 equal to f of x0 divided by x0 minus x1, and taking minus common from the denominator, and then this will be minus become plus, and we write this f of x1 divided by x1 minus x0. So this is the value of the divided differences f of for two arguments x0 and x1. Now if we consider divided differences between these two x1 and x0, then by definition this is x1 minus f of x0 divided by x1 minus x0, separating numerator f of x1 divided by x1 minus x0 minus f of x0 divided by x1 minus x0 equal to f of x1 divided by x1 divided by x1 minus x0 minus plus f of x0 divided by x0 minus x1. Now see these two values of the right hand side. The two values are same, f of x0 divided by x1 minus x0, f of x0 divided by x0 minus x1, f of x1 divided by x1 minus x0, and this term f of x1 divided by x1 minus x0. So whenever the right side equal, left side is also equal. That means f of x0 comma x1 equal to f of x1 comma x0. So what we have done here, when we change the order of the arguments, the value of the divided differences remain unchanged. Now let us check for three arguments, f of x0, x1 and x2 equal to, by definition, f of x0 comma x1 minus f of x1 comma x2 divided by x0 minus x2 equal to, we write this as 1 divided by x0 minus x2, and for this 2 we apply this definition. This is f of x0 divided by x0 minus x1 plus f of x1 divided by x1 minus x0 minus, in bracket, this is f of x1 divided by x1 minus x2 plus f of x2 divided by x2 minus x1 equal to 1 divided by x0 minus x2, f of x0 divided by x0 minus x1 plus f of x1 divided by x1 minus x0 minus f of x1 divided by x1 minus x2 minus f of x2 divided by x2 minus x1 equal to 1 divided by x0 minus x2 f of x0 divided by x0 minus x1 plus, from these two let us take f of x1 common. F of x1 here, x1 minus x2 minus x1 plus x0 divided by x1 minus x0 into x1 minus x2 minus f of x2 divided by x2 minus x1, x2 minus x1. Now here x1 get cancelled, and here look at this, x0 minus x2, right? Then this is equal to f of x0 divided by x0 minus x1 into x0 minus x2 plus this x2 minus x1, x0 minus x2, and this x0 minus x2 will be cancelled, and we get f of x1 divided by x1 minus x0 into x1 minus x2. And here x0 minus x2, we write this as x2 minus x0 with minus sign common, and minus minus will be plus, and we remain with f of x2 divided by x2 minus x0 into x2 minus x1. So for three arguments we get these values. F of x0 comma x1 comma x2 equal to f of x0 divided by x0 minus x1 x0 minus x2 plus f of x1 divided by x1 minus x0 x1 minus x2 plus f of x2 divided by x2 minus x0 x2 minus x1. This is the value of the argument. Now what happen if we change the order? Instead of if we replace this, let us suppose if we calculate x1 comma x0 comma x2, let us check this, and we will see whether we get the same value or we get the different values. Again, by definition, this will be f of x1 comma x0 minus f of x0 comma x2 divided by x1 minus x2 equal to 1 divided by x1 minus x2 into f of x1 divided by x1 minus x0 plus f of x0 divided by x0 minus x1 minus in bracket f of x0 divided by x0 minus x2 plus f of x2 divided by x2 minus x0 equal to 1 divided by x1 minus x2 in bracket f of x1 divided by x1 minus x0 plus. Now from these two, let us take f of x0 common, f of x0 as a common term, and LCM. So LCM x0 minus x2 minus this x0 plus x1 divided by x0 minus x1 and x0 minus x2, and minus f of x2 divided by x2 minus x0. So x0 get cancelled, and we have x1 minus x2, this factor. So when we multiply by this factor, this will be cancelled, and we have now f of x1 divided by here x1 minus x0 into x1 minus x2 plus f of x0 divided by x0 minus x1 into x0 minus x2. Okay, now look at this. This is x1 minus x2 and this minus. So we take minus common from here and minus minus will be cancelled and we remain with f of x2 divided by x2 minus x0 into x2 minus x1. Now see this value and this one. So this will be same. So whenever we change the order of the arguments, the value of the divided difference will be remain same. So assume that this result is a hold for n arguments. The results then, by assuming the nth divided differences, we have f of x0 comma x1 up to xn, then f of x0 divided by x0 comma x1, x0 minus x1, x0 minus x2 up to x0 minus xn, plus f of x1 divided by x1 minus x0, x1 minus x2, x1 minus xn, plus f of xi divided by xi minus x0, xi minus x1, xi minus xn, plus f of xn divided by xn minus x0, xn minus x1 dash dash xn minus 1. So this is the nth divided differences. And look at this the denominator of every factor, f of x0, x0 minus x1, x0 minus x2, x0 minus xn. Here the factor x0 minus x0 is omitted. F of x1 divided by x1 minus x0, x1 minus x2, x1 minus xn. Here x1 minus x1 is omitted. So here whenever we take the in the nth divided difference, the coefficient of f of xi, it is 1 divided by xi minus x0, xi minus x1 and xi minus xn. Here the coefficient xi minus the term xi minus xi is omitted. Okay, so we assume that this result is true. Now if we consider the n plus 1 divided differences, x0, x1, xn up to xn plus 1, then 1 divided by xn plus 1 minus xn plus 1 minus x0, this is equal to f of x0 comma x1 up to xn minus f of x1, x2 dash dash xn plus 1. Then in this term, the factor of the n plus 1 divided differences, this will be 1 divided by xi minus x0, xi minus x1 up to xi minus xn plus 1. So we have this factor and this is equal to 1 divided by xn plus 1 minus x0 into 1 divided by the factor this is equal to, the factor will be f of x pi xi, this is coefficient. Okay, so let us consider the only coefficient of this, coefficient of f of xi, then coefficient of f of xi, this will be xi minus x0 up to xi minus xn minus 1 divided by xi minus x1 up to xi minus xn plus 1. Okay, and then this will gives us here, look at this will be the coefficient having xi minus x0, xi minus x1 and xi minus xn plus 1. So if we take the LCM of these two, LCM of these two, and then solving this bracket we get this term. So coefficient of f of xi in the nth divided differences is 1 divided by xi minus x0, xi minus x1, xi minus xn plus 1. Okay. Then it is true for n plus 1. Now we have proved that you have seen that the value of the nth divided differences or any divided differences is same, and irrespective of the order of the divided differences. We have proved this for n is equal to 1, n is equal to 2, and by assuming it is true for n is equal to for nth divided differences, and we have seen that for n plus 1th divided differences, the value of the coefficient of the nth divided differences is independent of the variables, and whenever we change the variable, the value of the nth divided differences is remain same when we change the order of the arguments. So this shows that the nth divided differences or the divided differences are symmetrical in all their argument, that is the value of the nth divided differences is independent of the argument. So this is the important theorem which we have proved here. Now let us consider another property of the divided differences. If we see the polynomial, if the polynomial is nth degree, suppose f of x equal to x raised to n, this is the polynomial, and in this polynomial, if we consider the divided differences f of x r plus 1 comma x r, then by definition this will be f of x r plus 1 minus f of x r divided by x r plus 1 minus x r equal to x r plus 1 raised to n minus x r raised to n divided by x r plus 1 minus x r. Now one factor, common factor is x r plus 1 minus x r. So common factor from this numerator, we cancel out that common factor, and we have now x r plus 1 raised to n minus 1 plus x r plus 1 raised to n minus 2 into x r plus x r plus 1 raised to n minus 3 into x r whole square plus x r plus 1 x r raised to n minus 2 plus x r raised to n minus 1. So what we get here, the first divided differences for this polynomial are it's a polynomial in n minus 1/8 degree, homogeneous polynomial. It is a degree of this polynomial is n minus 1, and it is a homogeneous. So first divided differences are when the polynomial is of nth degree, the first divided differences are we get it is of n minus 1/8 degree. Now let us calculate the second divided differences xr minus here, okay, f of xr comma xr plus 2 xr plus 1 comma xr plus 2, this is equal to 1 divided by xr plus 2 minus xr into f of xr plus 2 comma xr plus 1 minus f of xr plus 1 comma xr equal to 1 divided by xr plus 2 minus xr into xr plus 2 raised to n minus 1 plus xr plus 2 raised to n minus 2 into xr plus 1 plus xr plus 2 raised to n minus 3 into xr plus 1 raised to square plus xr plus 2 into xr plus 1 raised to n minus 2 into plus xr plus 1 raised to n minus 1. This is the first polynomial, n minus 1n degree polynomial for in the two variables. Now this will be the minus, so we have minus xr plus 1 raised to n minus 1 minus xr plus 1 raised to n minus 2 into xr minus xr plus 1 raised to n minus 3 into xr square minus xr plus 1 into xr raised to n minus 2 minus xr raised to n minus 1. Okay, so this term will be cancelled. Now 1 divided by xr plus 2 minus xr into, look at this here, xr plus 2 raised to n minus 1 and xr raised to n minus 1. So xr plus 2 raised to n minus 1 into xr raised to n minus 1. This is a one term plus here xr plus 1 and here xr plus 1. So xr plus 1 is a common factor and we get xr plus 2 raised to n minus 2 minus xr raised to n minus 2. So in this manner plus we write in terms of these types. So continuing this manner, here xr plus here we get xr plus 1 raised to n minus 2 and xr plus 1 raised to n minus 2, this term, look at this, and the factor is xr plus 2 minus xr. Okay, so every term contain xr plus 2 minus xr as a factor, xr plus 2 minus xr as a factor, xr plus 2 minus xr as a factor. So this cancelling the common factor, whenever we cancel the common factor we get xr plus 2 raised to n minus 2 plus xr plus 2 raised to n minus 3 into xr plus xr raised to n minus 2 plus xr plus 1 into here xr plus 2 raised to n minus 3 plus xr plus 2 raised to n minus 4 into xr plus xr raised to n minus 3 plus xr plus 1 raised to n minus 2. So look at the degree of every term is raised to n minus 2. So it is an homogeneous polynomial again of degree n minus 2. So first divided differences of this polynomial are of degree n minus 1. The second divided differences are of degree n minus 2. So similarly, if we continue this in this manner, if we calculate the mth divided differences xr comma xr plus 1 up to xr plus m, then is a polynomial. This will be a polynomial of degree n minus m, and therefore the nth divided differences, first divided differences are n minus 2, second divided differences are n minus 2, and hence the nth divided differences is of degree n minus 1, n, that is 0, and 0 degree polynomial is nothing but a constant polynomial. So whenever there is a polynomial of degree n, the nth divided differences of the polynomial, nth degree polynomial are constants. So we get this second important property of the divided difference is that the nth divided differences of a polynomial of nth degree are constants. Okay, so now friend, I hope you got the important properties. Thank you for watching the video.